Oh yeah.
Well,
Peace to the family. Peace to you, Miss Juju. How you doing?
peace, Anthony. I still see we got to learn how to dry this tank, but we'll be all right.
Yeah, I may have messed up a few lawns, but the grass will grow back.
That's okay. Well, bump them plants. Bump that
It'll grow
grass.
back.
It'll grow. It'll grow back, but
most definitely.
But thank you, ladies and gentlemen, for joining us tonight. First and foremost, we want to apologize for the delay due for unforeseen circumstances. Like some of us got to work, and sometimes, it just be what it be. You feel me? Trying to rush home and get it in, but here we are. So we thank y'all for being patient and bearing with us. And without further ado, we're just gonna get right into it. So for this first season, I'll probably always read our mission statement because I really want people to understand, why we're doing what we're doing and the reason for us being here and putting in this work. So welcome to our Galaxy and Beyond with Anthony and Juju. And we decided to do something a little different, switch it up, change the narrative a bit on the current scope of conversation in the community. We also wanted to motivate and stimulate scientific interest amongst the people of our communities, especially families, with the hopes of positively impacting the lives of our children, who are our future and our legacy. This show, Our Galaxy and Beyond, will primarily be focused on the latest news and discoveries concerning the James Webb Space Telescope, or known as the JWST, and all things concerning space science, our galaxy, and our universe. But of course, we may include other matters of science that we deem important or just fascinating. We also want to be a resource for scientific information, such as YouTube channels and other social media links, providing access to science programs, space camps, training courses, events at your local university or planetarium, and anything that is geared towards allowing one to become actively engaged in increasing scientific literacy or training and education that could possibly lead to one becoming an expert in a science-based field or profession. And with that said, ladies and gentlemen, this is Our Galaxy and Beyond with Anthony Juju, and this is season 1, episode 3 of the Orion Nebula, When the Rubber Meets the Road. Anthony?
Yo, what's happening, everybody? Thank you for that, Miss Juju, as always.
Absolutely.
I want to say peace to the chat. Appreciate everybody coming in. Real life is real life. So, but we will be on time next week for sure. But let's get right into it, Miss Juju. This is someone, this a hot topic for me. So,
all right, we're gonna get right into it. So basically what we do, and Anthony and I both, I follow lots of scientific magazines or websites, journals or whatnot, but particularly like NASA.gov and space.com are really good. There are also others like the European Space Agency. They have a really good website that gives you all the latest that's going on, especially with the James Webb Space Telescope that was launched last year. I believe it was July 22nd, 2022, if I'm not mistaken.
In December. It was.
I'm sorry, it was launched in December. Christmas 25th, but the 2021. Thank you for the correction. But the first images it got was during July. Sorry, I confused that. My apologies, I misspoke. Was in July 2022. And lately, it's been really giving. It's been giving, right? It's been giving a lot of awesome material. And this current piece of information also just happened within October. And it was basically some photographs of the Orion Nebula. So if some of you are aware, this wouldn't be the first time that the Orion Nebula has been photographed or we've done any type of research on it. The Hubble spacecraft have some absolutely amazing pictures of the Orion Nebula, but the James Webb Space Telescope, like amazing times a trillion, because the photos that the James Webb Telescope gave us the Orion Nebula are absolutely beautiful. So to get right into it, first I'm going to share my screen, and then I'm going to give you a little bit of food to eat. And Anthony's just going to fill in the gaps for me. So this first piece, and I hope I don't get the right one. Nope. All right. Let me know if you can see my screen, Anthony.
Yes, ma'am.
All right, getting right into it. So the Orion Nebula, which is one of the brightest nebulae that can be seen with the naked eye, is located within the Orion constellation, just below Orion's belt. This astronomical site is known as part of the Orion Molecular Cloud Complex, a stellar nursery. The OMC is located in our galaxy, the Milky Way, and is 1,344 light years away from Earth. That makes this the closest region to the sun that has massive star formation. And not only does it include like big massive stars, but also very young budding stars. This is what makes this particular nebulae attractive to scientists. And with that, what I mean about it has all stages of basically stellar formation in the Orion Nebula. We're just now in this discovery figuring out some really awesome things, and basically what this show is to tell you about a particular find that's very interesting. So a lot of times when you're dealing with scientific endeavors or trying to find answers to scientific questions, you actually are going into Pandora's box, and you may come out with more questions than answers. It's not a bad thing. It just means that we have a lot more to, you know, research and study and work on, but still getting closer to the answers that we first sought out firsthand. The picture that I'm showing you is Orion, and if you can see my cursor, can you see my cursor? I'm circling around Orion. Let me see if I can get it a little bigger for you.
You might need to blow it up a little bit.
I am. Let me see if I can make this larger. Did that get bigger?
Let's see. But I mean, I think, yeah, I made it full screen. That's the best I can do.
Okay. So, ladies and gentlemen, this here, if you can see my cursor, there's like almost this red-looking star here. Looks like a red giant. And you have this bright star here, and you have these bright stars at the bottom. This would, if I'm not mistaken, be the sword region, but this whole constellation is considered the Orion constellation. And this right here is Orion's belt. And actually, I'll get into it later, but these three stars are considered asterisms, which is similar to a constellation, but not quite the same. And right below...
They're a group of, excuse me, Miss Juju, an asterism is a grouping of stars within a constellation, or they make up part of the constellation.
Right.
That's basically what an asterism is. And this Orion constellation is known as a winter constellation. So if you go out tonight, maybe about 10:30ish, 11, you'll see it coming up over the east, out of the east, and it'll be up all night. It'll be up till sunrise, that whole constellation.
So this part right here would be considered what we call the Orion Nebula. It's right below the belt. If you're trying to find it in the night sky, it'll be right below. This is the Orion's belt, and the brightest spot right underneath would be the Orion Nebulae, which is the focus of our conversation. But more importantly, it's not just the Orion Nebulae, but the pronounce one more time, the
asteroid?
No, the trapezium.
Huh?
Trapezium.
The trapezium. Yeah, the trapezium.
The trapezium cluster.
Yeah, it's
Yo,
a
I was
region
talking
of
about
4 stars that sit
yeah,
right in the center of it.
I was talking about the trapezium earlier, y'all. He was like, that is not trapezium, that's trapezium. I was like, Lord, thank you. Thank you, you told me. So there are approximately 2,800 young stars within the Orion Nebulae. Even stellar embryos, cocoon, which are newborn stars still wrapped in cocoons of dust and gas and other planet-forming materials. This stellar nursery has young stars at all ages of development that are shrouded with hydrocarbon-rich filaments. The Orion Nebulae can reveal to scientists a great deal on how stars and planetary systems come to exist and how they are formed. The observation of young stars, the protoplanetary disk, and brown dwarfs, intense turbulent motions of gas, which includes the jets and outflows, photoionizing effects of massive nearby stars, and free-floating planets or planetary mass objects. So the Orion Nebula has so much, how can you say, like astronomical phenomena going in there. Now, I know I just read you off some big words, so I wanted to define some of these words to you. And the first one I'm going to do is nebulae or nebula. That is important because it's actually a very distinct luminescent part of an interstellar medium, which that would be the Orion Nebula or the constellation Orion, which can consist of ionized, neutral, molecular hydrogen, and cosmic dust. They're often star-forming regions. So usually when you hear nebulae, it's going to be a region where stars are being born. No pun intended, maybe a little. The formation of gas, dust, and other materials start to come together to form dense regions, which attract more matter and become dense enough to form bright stars. And if you want to go into that briefly and explain how that works from, just a clump of matter becoming an object of something that can glow and what that take, Anthony, go right ahead before I move on.
Yeah, that what it is gravity. There's
right.
that portions of that nebula, depending on the size of it, it starts gravity starts to take effect and starts to pull in the gas and dust together as it's spinning. And the more it attracts, it has to reach a limit. But once it reaches that limit, nuclear fusion takes place. So that's when the star is born. Just quick synopsis. Gravity takes over inside the nucleus. Inside the nebula, and then as it reaches a certain limit, nuclear fusion starts. Now you got a star is born.
Also, what I thought was interesting is they have so much in here as far as like a lot going on. Like really studying for this project was way more than what I thought. And Anthony told me in the beginning, like just take a little piece, because even what you think is a little piece is going to be way more than what you can imagine. One other important piece of this is the Orion Molecular Cloud Complex. I had to give this one to you because this is the important part of the nebulae, which the James Webb Space Telescope focus on into, and I'll really get into how and why later. It had something to do, one, with the technology of the James Webb Telescope, being able to see through the dust particles and these gaseous forming clouds where visible short wavelength light can't really penetrate. But because James Webb has engineering and technology on there that has long wavelength infrared technology, it can penetrate through these gaseous clouds to see, what's beyond. Also, some of the astronomical figures in this molecular cloud complex, or the
Trapezium.
trapezium star cluster. I'm gonna kill that word. Keep correcting me.
It's okay. You cooking.
Because
It's
like
okay.
brown dwarfs, since they don't emit much light, a lot of times, the light will get faded out. So the James Webb Space Telescope is designed specifically to not interfere with that. And I'll talk a little bit more about that later. But the Orion Molecular Cloud Complex is a star-forming region with stellar ages ranging up to, and stellar meaning the stars that are forming, whether they're really baby young stars or the older stars, they range up to 12 million years old. Two giant molecular clouds are part of the Orion Molecular Cloud Complex. These clouds are Orion A and Orion B, and the stars currently forming in this complex are located in these clouds. So the ones that are forming right now are in this cloud. The Orion Molecular Cloud Complex is 1,000 to 1,400 light years away and hundreds of light years across. Okay. And I think I wanted to go ahead, Anthony, because I also wanted to share one more piece.
Okay, go ahead, get it out.
No, you talk, and then I'm looking for the picture right now. Just want to bring it up.
The importance of Webb, like we've spoken on before, is it detects in the infrared. We've been able to study, the Orion Nebula forever. I mean, ancient civilizations, actually looked at it and discussed it, recorded it. But this is the first time we've ever been able to actually peer deep inside all of the dust and, thick gas that makes up the Orion Nebula. With James Webb and that NIRCam, that near infrared and that mid infrared, they're able to detect the heat signature, that the dust and stuff, it blocks out a lot of the visible wavelengths of the spectrum. But that Webb with the infrared technology, it's able to peer a little bit deeper into the nebula and made some nice, it confirmed some things, but it also made some new discoveries. And it's some new questions coming up now. Now we've answered some questions about the Orion Nebula, but now there are new questions, so that's the most exciting thing about, astronomy for me. It's, you get to answer questions, but 9 times out of 10, and that when you answer something, probably gonna have about 2 or 3 more questions coming, so now we got some more work to do. And, as I always say, this is an avenue where, you can get your kids in it and they can actually make a career out of astronomy. What I'm saying? They can make a career out of it. And this is a nice one here, Miss Juju. This protoplanetary disk.
So these are protoplanetary disks. But before I get into that real quick, I'm going to share a few things to you so you understand exactly how and why that works. So in the nebula, because I want y'all to be able to visualize this, and in a minute, I'm actually going to show you a simulation, and Anthony's going to walk you through it, exactly what it is. But there are 2,800 young stars within Orion Nebula, even stellar embryos cocooned, which are newborn stars still wrapped in cocoons of dust and gas, planet-forming materials. This stellar nursery has young stars of all ages of development shrouded with hydrocarbon-rich filaments. The Orion Nebula can reveal to scientists a great deal of how stars and planetary systems come to exist and how they are formed, which is one of the major questions that scientists are actually having. And this is one of the major endeavors of the James Webb Space Telescope, believe it or not, to figure out how do solar systems come to be what they are, how do stars form, and how are planets formed around them. And even though they've answered some of these questions to an extent, they've also, with the answers, they've also gained a whole new set of questions with the discovery that we're going to tell you in just a minute. So the observation of young stars, protoplanetary disks, and brown dwarfs, and intense turbulent motions of gas, which include the jets and outflows, photoionizing effects of massive nearby stars, and free-floating planets or planetary mass objects. So in the picture that I'm showing you now is the protoplanetary disks is what we're getting at. And I'm trying to make these as big as possible for you. Does that seem pretty big right now? But all these are protoplanetary disks. All of them come in different sizes and ranges, depending on, the age or the stage of this so-called newborn star. But this is what it looked like. And this image is actually from a James Webb Space Telescope. And then, I'm sorry, my apologies, I misspoke. These are images from the Hubble Space Telescope, not the James Webb. What I'm about to show you now, which I think will blow your mind, is from the James Webb Telescope. And while I'm showing you that, we will get into exactly what a protoplanetary disk actually is. And then I'll let Anthony explain a little bit about this photo, and then we'll do the simulation. Can you see that clearly, Anthony?
Yep.
And now this photo right here is by the James Webb Space Telescope and pretty recent. And it has some pretty awesome astronomical features in this one photo. Like, amazing, absolutely amazing. So, a protoplanetary disk is basically a rotating circumstellar disk of dense gas and dust surrounding a newly formed star. A circumstellar disk is a torus. And this is a type of motion or movement. We won't get into that now, but we definitely will come back into it when we do our next season. We're just strictly dealing with stars. So if you're taking notes, just hang on there. But the circular stellar disk is a torus, pancake or ring-shaped accretion disk of matter composed of gas, dust, planetesimals, asteroids, or collision fragments in orbit around a star. For young stars, they are the reservoirs of material out of which planets may form. And there was also a term that I mentioned about photoionization. And this one was pretty interesting because it's basically the physical process in which an ion is formed from the interaction of a photon with an atom or molecule. And even though that sounds like much, it's basically the process that makes once an invisible filament in deep space glow. So this is what gives that glow property, okay? And for the photo, did you want to run through it, Anthony, or did you want me to do it?
Yeah, I can talk about it. Yeah,
I was going to let you talk about it, then I was going to do the simulation video real quick, if you like.
Okay, that'll work. Yeah, but each one of these smaller boxes is showing, it's, if you look at it on the bigger picture, it's letting you know where it's coming from. And you have stars in different stages, of their evolution. And you have it's just in that one area, you got all of this going on and a whole lot more, So, like I say, you can look at each box and it'll tell you, if you start at the top left, you have a young star inside, a globule. It actually just turned on, the nuclear fusion has just started. That's one stage.
Mm-hmm.
Then you look at the Orionis A. If you go down, that's a full-fledged star. You know, he's
This
doing
is.
his thing. You know what I'm
Let,
saying?
I want to interject because I'm getting to this too. I'm giving y'all a little more, but this is called Theta Orionis A, and this is the Bayer designation, which I'm going to discuss a little bit later on. But continue, Anthony.
Okay, and then if you go over to the right, lower right corner, you know, you see the filaments. So that's what it looks like when the whole
Oh, right
process
here,
is actually getting ready to start. Yeah, the
filament.
bottom. Mm-hmm.
Mm-hmm.
And then if you go up to the top, the top right,
This is the
yeah,
cocoon.
yeah, you have a young star with the disc inside, you know, of its
Mm-hmm.
cocoon. It's just getting ready to turn on. You
That's
know.
the embryo star. That's the baby
Yeah,
star.
and
Oh,
you have all of this going on, plus much more. You know, you can find just by studying this one region of the sky, just this
right.
one little small patch of sky. You have pretty much the evolution cycle, well, from birth to maturity of a star, just right there in that one region. You know, just imagine what's going on in the rest of the of the universe. But this is just a few light years, with what, about 1,000, 1,400 light years or something like that
Yeah.
away from us, and maybe a
1,000 to
thousand light
14.
years. Yeah. So you
And
got all that. You can learn all of that about stars just by studying that one area of the sky. That's what's amazing to me about, you know, astronomy.
yeah, I think they give their approximations for the distances because the whole Orion molecular cloud complex itself, and even like the traps, the was it trapezium?
The trapezium.
Trapezium, I'm not gonna get it. Even the trapezium cluster, like all those have a span or distance of 1 or 2 light years themselves, as far as like
Mm-hmm.
length or how far they go. You get what I'm
The
saying?
distance. Yeah.
I'm sorry.
No, I'm just saying the distance.
Right, but I mean, but they were also measuring that as far as like, the span. So from Earth, one part of that may be so many light years away, then the other part of that may be, a couple more hundred light years away, because it's also so many light years within itself. Did I explain that clearly enough, Anthony?
Oh yes, ma'am. You did a great job with that. It's
So
all
that's
of
why they'll
that.
give you.
You know, when we look at this, you know, like you said, it's certain parts of it, or you know, it's different distances. I mean, we talk about how vast the universe is. You know, I mean, when we think about it. We've mentioned this last week. The
Mhm.
nearest star to our solar system, it takes the light 4 years to travel. It's
Right.
4 light years away. You know what I'm saying? This area of the sky is about 1,000, if I'm not mistaken. Y'all can fact check me on that. But it's like 1,000 light years away, or maybe even farther. No, it could be farther. It might be like, I can't remember. Just, you know, look it up. But anyway, the moral of the point of the story is the distance is just, we can't imagine that. You know, there's no technology that we have that we can get an understanding of 4 light years. So each area of this, you know, these discoveries, they're pretty far away. You know, that's a long way away. So we need the tools. You know, we need things like Hubble and James Webb to really get an understanding and try to apply that to how our solar system started. You know, and it's looking at these things like this, we can get an understanding of how our solar system was formed. You know.
Right. And before I show you that simulation, I'm just going to give you a little bit more food for thought. So when we're showing it to you, you definitely understand the process of the technology and what's taking place. You know, I'm trying to put you there with the James Webb Space Telescope as it's assessing these astronomical objects and figure. So the technology which we spoke of earlier on the James Webb Space Telescope has been able to reveal a much clearer and detailed picture on what's really going on inside the Orion Nebula. Its near-infrared camera, which is known as the near cam, has the ability to see through the nebula's dust and gas clouds, where visible wavelength light, and I discussed this earlier, cannot penetrate, but long wavelength infrared light can. The near cam short wavelength channel, because actually both cameras, or they say channel sometimes, was used for this, the long and short, but they both gave different results as far as resolution and what they actually were looking for. Okay, one is a more sharper image. I'm giving you all the astronomical objects very clearly, and the other one is a little bit more detailed as far as really giving you a picture of the gaseous environments and the filaments that's in the nebula, and all the elements of that. So the short wavelength channel was also used to capture the nebulous star forming activity at the greatest angular resolution. There are a few important factors on why the James Webb Space Technology is well suited for this project. Young forming objects don't accumulate enough heat in order to emit visible wavelength light, enough to make them glow. And so with that, most of their light is actually emitted in infrared. James Webb is perfect for that. Also, the James Webb Telescope is above Earth's glow. So with infrared objects, like everything that has some sort of heat is actually going to glow. So if you have this glow, a really faint object, you won't be able to detect it or see it. So because it's above the Earth's glow, and also the ability for the James Webb Space Telescope to cool itself down to very low temperatures where the object itself doesn't emit any type of like light interference, it minimizes any disturbance of light being emitted by very faint or low mass objects, which that is important because things like, you know, brown dwarfs are considered like low mass objects. And also like some of the newer stars, and the point of our article, these, which we'll get into in a minute after this simulation, after our commercial break, these rogue planets. So hold on to that. But right now I'm going to do a quick simulation for you all. And I think you all will really enjoy this. And then we're going to take a quick commercial break and we're going to get right back to it. Give me just a moment, Anthony, if you want to say a few things about what I just said while I get this.
Yeah, I'll just add that in this, you know, this simulation is pretty dope. But, you know, with Webb, you know, its capabilities, man, it's just, like I said, we got new questions that need answers. You know, that's what this is all about. You know, so being able to basically see the stars and what's happening around them, that's, you know, that's what's up, you know. But you can go ahead and play it, Miss Juju. Yeah, this was put together by Hubble, you know, a few years back. It's basically, they'll just be taking us through the work that Hubble has done. You know, they put it together in a nice, you know, nice little package here. But it's pretty good. Y'all check this out. But, you know, Webb took us deeper But this is pretty good for the capabilities of Hubble.
I'm pressing play.
Okay. Yeah, we're flying. We on our way there. Sit back and enjoy the ride. We astro projecting.
Don't do it. Yeah.
But yeah, that's the Orion Nebula right there. So and they're breaking it down. They're showing you the view from Hubble and a view from Spitzer, which is an infrared telescope, or basically the precursor to James Webb. Spitzer is a infrared telescope as well, but it's not nearly as big or has the capabilities of Hubble. But this is what they use for this simulation. So we're actually going inside the nebula. You know, you can see all those stars, and they're going to show you, you know, just what's happening inside of the nebula. And keep in mind, this is Spitzer is also an infrared telescope, but it's not nearly as big or have the, you know, the capabilities of the Webb, James Webb. But yeah, they showing you, you know, the trapezium, those 4 really big bright stars. There's, you know, protoplanetary disk flying by. You know, they've discovered brown dwarfs in there. They've discovered, you know, rogue planets. But what we're gonna get into next is that discovery. There is where the new questions are gonna come in. So yeah, that's a quick fly through of the Orion Nebula. It's pretty nice, and that's like, you know, that if you look at that our flyer for this week, that's the picture that I took of the Orion Nebula, which we showed it last week as well.
On the thumbnail.
That's what it looks like in the infrared from Spitzer. Yeah, that was pretty dope there. And, you know, you can find that video on YouTube, on NASA. You know, there's a series that I like to watch. It's called How the Universe Works. And they have a whole show, you know, on that right there. That's a really, really good series. If you're really into the cosmos, get you a Discovery Plus subscription and check out on the Discovery Science channel. You'll find How the Universe Works. We got about 10 or 11 seasons. And I mean, I've been watching it a long time. You know, I got them. It's like a set of encyclopedias for me. You know, you'll learn a lot, and you'll be introduced to a lot of different, you know, scientists that are actually doing the work. You know, people that take the information and the data from Webb or Hubble or the Keck or wherever. The actual people that are getting that data and putting it to use and doing the work, those are the people that, you know, are on that series. You run into Neil deGrasse Tyson's, Hakeem Alusier,
Hakeem.
Lawrence Krauss, yep, Lawrence
How about us,
Krauss,
Hakeem?
all of them, Sean Carroll,
Yeah.
all
Tell
of
him,
them,
let him know. Hakeem is
Michelle Thaler, it's all of them on there. So, that's a good series to check out if you want to get into
that's hot.
The universe.
Yeah. Hakeem Alusier, I actually, dropped this hashtag in the description box, and get into our little commercial break. Should we play some music for the commercial break? We need some more tracks here, but I think I'm gonna play just a little music. But I just want y'all to go ahead and make sure y'all hit that like button. You know what I'm saying? Like and share the show for your family. And if you like what you're seeing and what you're hearing, please do feel free to hit that Cash App or me. Also, check out the description box. So if you want your Pseudo Killas sweater, a t-shirt, shirt, they say African, that Abjuware site up, Abjuware.com, all your they say African and Pseudo Killas apparel. Okay? So, give it a few minutes, but make sure y'all hit that like button, like and share the show. Share it with your friends, your family, your grandchildren, your niece, and your nephews. This is a rah-rah free zone. We don't do no rah-rah here. We don't do no gossip. It's straight information, facts, and science. You feel me? And as soon as we take this quick little commercial music break, I'll give you our weekly link shares. Two amazing links I have for you to help increase your scientific literacy. And I think you'll love these links I'm about to give out to y'all. So y'all just stay tuned, about 30 more minutes. But yeah, go ahead and hit that like button, share the show, ring that Cash App. I'll take $1 from everybody in the crowd right now. You know what I'm saying? But we do thank you all for coming out and joining us. We do appreciate the support. And remember, we're going to be here every Wednesday, 7 o'clock, sharp on the dot, to feed you some more, little bit of astrophysics, a little bit of more science, a little bit on what the James Webb Space Telescope is doing for us in the future of astrophysics future. So yeah. How you feeling, Anthony?
I'm feeling great. Like I say, this is my subject, this is my lane.
I know it is. You be rocking out. I be in school. Yeah.
Hey, every Wednesday.
Every Wednesday, 7 p.m. We're going to be here. We ain't going nowhere. I'm back in school. Put it on your calendar. Subscribe to the channel. Hit that notification button. Make sure that you don't miss out on notification of this show and some of our other great shows we have currently going every Sunday night around 6:45 p.m. And our series right now is on the brain. You definitely don't want to miss that. Those are some hot conversations. We do an impromptu show where it's like open panel. Just come in with your questions. Tell us what you think. You get what I'm saying? And we just don't, talk about it a little bit. Get into a bigger conversation we'll have later. But yeah. Thank you, DQ. Shout out to DQ for all the hot music. We do appreciate that. Well, yeah, that's our commercial break.
Hey, let's get into these new questions though. I'm ready to get into these new questions.
Oh, you got some questions already?
No, I'm talking about the article, but the new questions that James Webb is presenting.
We're going to get into it right now in 30 seconds. But right now, also, I want people to remember in the description box, I have what we call our link shares for the week. Remember, every week we'll be coming with some link shares for you about different programs or websites, space camps, planetarium schedules, anything that I hope gets you more actively engaged and becoming more scientific literate, especially in this subject matter. So our first link share is actually one of my favorites. I follow this young lady on Instagram, and her name is Astro Alexander. And of course, in the description box, the links are there for you easy. So just press on them and it'll take you right to the site. But she's considered a professional space communication specialist, which she acts as a translator for scientists and engineers. And her goal is to make the universe more accessible. Her information is pretty high. Everything she talks about is not totally on astrophysics. She does a little bit of everything. I know one of her latest clips had to do with a nuclear fuser or infusion or something, but I don't want to lie, but you just check it out. Just click the link and go to it. But it was something about getting hotter than the sun on Earth. Yeah, it was real interesting. And our next link share is again from the European Space Agency, and it's called the ESA Sky app. So it's the European Space Agency Sky app, which is an interactive all sky map with the user-friendly interface that enables its users or members of the public to view some really amazing images of the universe taken by the James Webb Space Telescope and the Hubble Space Telescope. So please check that out. So some of these images you're seeing now, you will also find on the ESA Sky app. And that link to the ESA Sky app is definitely in the description box. So check that out after the show. All right, so getting into it. So one of the major finds, and I'll skip over that, maybe we'll come back to it. One of the major finds that the James Webb Space Telescope found recently, and while we're really doing the show, we just wanted to give you all a little foundation, is the discovery revealed of 40 pairs of free-floating gas giant planets, otherwise known as Jupiter mass binary objects, or a really cute acronym. They call them jumbos. The JU for Jupiter, the mass binary objects. Even though rogue planets are not new to the Orion Nebula, we've found rogue planets before this time. These jumbos are significantly special due to their binary properties. So right here is something that we've never seen before, and let me get right into it. So meaning that all of them came in pairs. So not one rogue planet, but two. And not just as a singular rogue planet, but their own independent binary system, meaning that they are gravitationally bound by each other. So you basically have two planets that are held together. You know, you'll tell me more if they're spinning or not. I don't read any of that, but they are together, just chilling. Separate objects, but chilling planets. Oftentimes we hear about binary star systems, but never binary planet systems until now, something we never knew was possible. So this is where I say, you know, you'll go into it and you'll be looking for answers to the questions we already have and end up coming out with more questions. Anthony?
Yeah, this is exciting to me for the simple fact that it's something new. It's new questions being asked. So we have these planets, that are gravitationally bound to each other. They're orbiting a center of mass, but they're just free floating. Now, like you said, the rogue planets, that's not new. That's something, we've known about. There's rogue planets here in our,
in our
all
galaxy.
over the galaxy.
Mm-hmm.
The Orion Nebula is part of this galaxy, but there's rogue planets all over this galaxy. And but they've never found them in binaries or in pairs, So how did they form? Where did they come from?
Right.
They're challenging what we understand about planet formation, because all we've ever known was the protoplanetary disk. Well, you have binary planets just floating through. They're not bound to any star. So that's something brand new, and that's gonna raise new questions. And now we have to challenge, what we already understand. And maybe it might change, but more than likely it'll just add to what we know. You know what I'm saying? Some things may have to be tweaked. But that's the great part about science. It's self-correcting.
Right.
You know what I'm saying? There are no absolutes in this. Our understanding of this stuff is not absolute. You know what I'm saying? So that's the great part and the exciting part about science when it comes, in my understanding.
Right.
So this is something new. We gotta go to work. So this is an avenue for our younger generations to get into, and like I say, and build a great career. And who knows, might lead to a Nobel Prize or whatever. You know what I'm saying? Could be the next great physicist or astronomer, or all starting right here. This is a brand new question. You know what I'm saying? So that's what's exciting to me, being an amateur astronomer. I love it. I
know you do. And so I want to back up a little bit, because the Trapezium cluster. Say it one more time for me, Anthony.
Trapezium. We're gonna get it though. We're gonna work on
it. So because I've been practicing trapezium cluster, also known by its Bayer designation Theta 1 Orionis, excuse me, is a tight open star cluster discovered by Galileo in 1617, which he sketched all three of the four of the brighter stars, which was A, C, and D. But B was later discovered by other people. But the important part of this is that, these bright stars have a solar mass. I want to give y'all a little bit more food, which is astronomical type scaling that calculates mass. So when it's one solar mass is like the mass of our sun, and they use that as comparison.
Yeah.
And when they are scaling other objects, like other stellar objects, like stars or stellar clusters, nebulas, galaxy, and black holes, they'll use this standard unit of mass in astronomy, the solar mass. So with that said, this solar mass is actually let me find my place. 15 to 30 times that of our sun.
So that's a very huge star.
Huge.
It's big.
Thousands of stars reside in the Trapezium cluster, but not all the planets here have a star. These are the rogue planets, and a planet without a star is called, the rogue planets. So this was one of the awesome finds of, that Trapezium cluster. Not the few that they already knew, but finding these binary objects that they had no idea were there. But again, that goes back to the technology and instrumentation, right? They didn't have the proper instrumentation, and a lot of the previous satellites couldn't penetrate through those gaseous clouds. Like one you saw in that real defined picture in the nebula where it had everything boxed off is called the Orion bar. And that's like a thick plume of, hydrogen filled, what's that? Hydrogen filled.
Kind of dust and all kind of stuff.
Dust, everything. So the James Webb was able to penetrate that. And also another important part of this latest discovery was the recording of the network of dust and organic filament compounds known as polycyclic aromatic hydrocarbons, which they call them PAHs. This was pretty awesome, y'all. So listen to this. These carbon-based molecules are abundant throughout the universe, right? Scientists are learning how they are formed. The reason why is because when I finish this, you're going to see the importance of understanding about these polycyclic aromatic hydrocarbons. These compounds are considered as starting materials for abiotic synthesis of materials quite required by the earliest forms of life. Abiotic, to define it really quickly, is just a compound of non-living chemicals and physical parts of the environment that affect living organisms and the functioning of ecosystems. This effect can be in terms of growth, maintenance, and reproduction. So basically, this phenomena aids in, you know, aids in some type of originating process, whether it be, you know, the planets forming, or perhaps even life forming on the planets or whatnot, or the stars forming. But they do know that it has some significance. PHAs are a major store of carbon. And we know that carbon is like, you know, carbon and hydrogen, right? Those are one of the basic, you know, fundamentals of life that we know.
Yep, all life is carbon based, so that's what makes
right.
it, you know,
Store of carbon.
interesting.
Say that one more time, Anthony.
I said life is carbon based.
Carbon
So
based.
that's what, you know, makes finding carbon in other parts of the universe
Exciting,
so exciting.
Right?
Yeah.
So, and seem to have formed shortly. These PHAs, or these polycyclic aromatic hydrocarbons, seem to have formed shortly after the Big Bang. So that's what makes it really interesting, and that's why scientists are really, really trying to figure out, you know, how this came to be, because they do believe this is a piece of that puzzle. You feel me? So are they trying to answer the origins of life, Anthony, or what's going on here?
Well, I think that's part of the question, but we
Okay,
also
okay.
just we want to just try to find some life somewhere.
Right.
You know what I'm saying? But most definitely, we trying. They trying.
So these PHAs are normally associated with new stars and exoplanets. Remember, when we talked about exoplanets before, these are planets outside of our galaxy, okay? On Earth, this compound can be found in coal and oil deposits, which I thought that was neat, because, again, it's pretty much everywhere in the universe, these polycyclic aromatic hydrocarbons. I thought that was interesting. Did I have a quick definition for polycyclic? I won't get into it, but it's okay. Yeah. And one last thing that I wanted to leave you all with. Some of the questions that still baffle scientists is did these jumbo planets, remember the Jupiter mass binary objects that we spoke of earlier, or other rogue planets come from or form directly from the Orion Nebula's gas as a filled star, or did they come from another planetary system where they were dragged away by the gravitational pull of a close passing star? These are still some of the answers that scientists are trying to answer. Like, how did these rogue planets come to be? Like, how can they just, you know, be there without a star, you know, holding them in their path? Because that's what we normally see, right? We see a star with planetary objects going around it, but this is absent here. And actually, we see two planetary objects together. So they're just trying to figure it out. Did it get kicked out of, you know, a galaxy and ended up in this, you know, cluster, or this what we call Orion molecular cloud complex, or, you know, the Orion Nebula itself, or, you know, or did they form from all this gaseous activity going on in the nebula itself? So, with the technology of the James Webb Space Telescope at our fingertips, the answer to these questions are in our grasp. And that, ladies and gentlemen, is the end of our show for tonight. There you have it. These rogue planets. Anthony?
Episode 3 in the books. Let me shout out the chat there, Miss Juju.
Oh, yeah,
Appreciate
go ahead.
coming in. Miss Gemini the Goddess. Appreciate
Gemini,
you.
hey, sis.
Sunchild, what's up, dude? Miss Bennett. Appreciate you coming through.
Sunchild's here.
Sakina Rob.
Arigato, Sunchild.
Miss Tiffany, my sister. Appreciate you, baby.
Lady Killer.
King Sosa. Hey, we're gonna slow it down for you next time, dog.
No, he was talking about
with
simulation. He's scared of roller coasters. You can't even take him to Disney World. I seen that.
Mungo Slave, appreciate you, doc.
Say Omar B.
Here.
Hey,
SBC podcast. Appreciate you. Mac Rob.
Nice.
Appreciate you, old boy. community of skeptics, my good brother Unc. Hey, y'all make sure y'all
Bobby
check
Stranger in
out
the building. Wait a minute.
that app you will.
The AbJuware link is in the description. So let me show you. So like hit the link and get your hoodie, your sweater for the winter.
There you go.
All nice and comfy. And it
Make
fits.
sure y'all check out that app you will.
Yeah.
Pure Black TV. Appreciate you, my brother. Omar Reed, what's happening, boss? Brad, my good brother. Appreciate you showing up, man.
Smalls in the building. Sorry, I'm butting
Brother Smiles in the building. My good brother
right.
Smiles. So yeah, that look like that's about it. Zane Montego, appreciate you, baby.
That's my dark Sienna brother. He knows it's my joke.
Yeah, but yeah, like I say, man, I appreciate everybody coming through. Miss Juju, I appreciate you.
Absolutely.
I really enjoy doing this with you. You know, the back and forth, the conversations we have about, these shows and what we gonna get into. Yeah. I'm into this here.
Right.
We got 3 already cocked and loaded, ready to go.
Cocked and loaded.
We ready to go. And like I say, every Wednesday, y'all tune in. I'm gonna apologize one more time. I had to work late. Wasn't expected, but it is what it is. But I do appreciate y'all hanging in there with us and showing up. We will be back next Wednesday, 6 p.m. Central, 7 p.m. Eastern. Make sure y'all in the building.
Let them know. Well, thank you. And with that said, we hit up a little Lady Killas anthem, and we just gonna be out of here. So we'll see y'all next week. We really appreciate it, everybody. Have a great night. Beautiful nightmares and sweet dreams. Oops. Well, that's okay. Good night, y'all. We out. Oh.